Okay, hi guys, I'm Sydney.
I'm Carter.
I'm Lou.
So today we're recording this video to demonstrate permutation tests in R, and we're doing this with a research question, which is, do red and white wine have different acidity levels?
Yeah, so we started out with two different data sets. So we had red wine and white wine, and they each were separated and had different characteristics for each wine. So we started out by using the read.csv, which will take a web link and put it into R, into whatever you call your variable. So we called it red wine and white wine for the data set relating to red and white wine. And then to make things easier, we wanted to merge the data sets. So to do that, we first added an extra column into red and white wine to specify the type of wine it was. So we did this by doing red $type equals red. So then within this new column, for all of the red wines, it'll have red inserted into this type column. And for white, it'll say white. And this will help us when we merge the data, because we'll still be able to know what type of wine it was when it's compiled and merged. So to do the merge, we did our bind, which will essentially just kind of stack the two data sets on top of each other vertically. And then to get a better understanding of this data set, we started out by doing column names, which will just tell you all the different columns. And you can see here type, which is the one that we added. So it shows different things like the acidity of the wine, the sugar, residual sugar, alcohol, quality pH, and we decided to look more at the fixed acidity. And to kind of also get a better visual representation, we downloaded ggplot2, which will help us get a pretty visual representation of the data. And to plot this, we did the data set, which is our data merged. And then for the aesthetic, it's our X variable is the acidity, and then we separated it based on type. And then we also added color based on type, so it'll color the two different types differently. And then we did a density plot, so this will be like a line graph, and everything under, if there's more values under it, it'll peak, which will show the density of values that are kind of congregated around that value. So when I run this, you can see the, you can see the plot that it generated. So the title is acidity by wine type. Let me try and make this a little bit easier to see. So the white wine is in blue and the red wine is in red. And you can see with this high peak here, it means that a large density, using that name of the, so the larger portion of the wines from our data set that are white had acidity values right around here. And based on this and where the peaks are, we can kind of see that the white wine has overall a lower acidity than red wine, which led us to form our hypotheses.
So below is going to be our code for the permutation test, and we used our p-value limit to be 0.05, which this would mean that if we get a p-value at the end of our code that's greater than 0.05, then there is not a statistically significant difference between the two acidity levels in white wine and red wine. And so we thought by using the graph above that we thought that there could be a significant difference between the acidity levels, and that's what we wanted to test. So for our null hypothesis, we used that red and white wine have no difference in acidity. And for our alternative, we said red and white wine do have a difference in acidity.
Yeah, so this is kind of getting into our code where we're randomly assigning the acidity levels of both red and white wine into two groups that combine both of them. So first of all, we would go through what we have is the set seed as 1, 2, 3, 4. This just makes our data replicable. So it randomly populates the same data every time. So every time we run it, we get the same data. We made vector r be 10 to the 4th, just a large number that we're going to repeat our trials in our for loop coming up. We made vector null dist. This is going to be the vector that populates in our for loop. We made it as well, and she can run it there, as we put it as -999, showing that at the end of this, if it also comes out as -999, that means that null dist was not populated correctly. And then we made vector temp. This is going to be the vector, this is going to be our mean acidity levels of both red and white wine completely. And you can see that there, 8.3, 6.8, red and white. So then we took those two levels and put them into OG test stat, which is that. Temp 1 is going to be our red, temp 2 is going to be our white. We subtracted the means of them and got that. That's going to be our OG test stat. Then we get the vector pool dat, which just isolates the acidity levels in the data merge set.
Yeah, so then once we get into our for loop, we ran it n times because that's what we set our n. We set our n to that large number, so it'll repeat it a lot of times to get a good representation. And then to start out, we populated a vector called these with a sample, and to just kind of get a better understanding of what this sample function does, we can run it down in the console. So sample will take a sample of a specified size from the elements of x, which is the first thing that we put in here. So our x in this case is 1 to the length of the data that we're utilizing. So we can see that it is 6,497 data points long. And then we did the size, sorry, that looks a little funny. We did the size to be the sum of every point that was red wine. Oh, why did that do that? So within our data, we had my goodness, it's not working with me today. There we go. Within our data, we had 1,599 wines that were red. So then when we populated these, we only sampled 1 through our length 1,599 times. So these is of length 1,599. So then to get an even better understanding, we can do just a small little example where we have sample 1 through 5 with size, let's say 2. So then it gave us 4 and 5. So what this is doing is it's randomly taking a value of either 1, 2, 3, 4, or 5, and it's picking 2 numbers from that. And that's essentially on a smaller scale what we're doing here. So instead of 1 to 5, we're doing 1 to the length of our data set, which was that almost 6,500. And then we're taking almost 1,600 data points from that. So this is just going to populate these with pointers that we'll then use later. So when we use these in our pool dat bracket these, it's then taking each of these pointers that we randomly generated. And so like for pointer 1, it'll point to the first data point included in our pool data, which is the acidity level. So then it's taking the pointers we generated and pointing them towards specific acidity values and then populating our fake red wine data set with these fake, acidity values because they're random. So then to get the white wine, the fake white generated or filled, we use the negative of these, which will take every data point that we did not use to fill fake red and fill fake white with that. Therefore giving us 2 new data sets, fake red and fake white, which will have, fake data sets of the acidity levels. And then to get our first data point in our null dist, we are taking the mean of all of the acidity values in fake red minus the mean of all of the fake acidity values in fake white, and then populating our first data point in null dist. So every time this for loop runs, which it'll run n times, this ticker of I will count up each time, therefore populating another data point within the null dist until it is 10,000 data points long.
Yeah, so then now we have a fully populated null dist. We can go in and plot a histogram of what null dist is. We can then, in the AB line, we plot a red line on that histogram. That is our OG test stat. And it takes
a second.
Yeah, it takes a second for the histogram. Like it always
Okay,
does.
so here's our histogram.
Yep, so that's our histogram, and we put in a red line to.
Hang on. Let me just run it all so that we make sure we all are getting everything ran.
Yeah.
Got mad at me. Okay, so here's our.
Yeah, so here's the histogram that we ran of the fully populated null dist. And then in the code, we coded to put a red line in there that represents our OG test stat. But as you can see in the graph, there's no red line, which means that it's way off the graph, meaning the difference between the values of null dist and our value of the OG test stat is way different. We can't even see it. Mm-hmm. So then going in, we want to figure out our p-value, our actual p-value. So we made vector tail 1, which is the summary of null dist less than our OG test stat, which is the number of values in null dist that were less than or equal to our OG test stat. We then made vector tail 2.
Which is all of them, too. Which
all
is
of them, correct.
Yep.
So which is 10,000, meaning it's just n to the 4th. Every data point in null dist was less than or equal to our OG test stat. Mm-hmm. So then in tail 2, we take the same thing, the number of values in null dist that were greater than or equal to OG test stat, and as you can see, it's 0 because none of them were greater than our OG test stat. Mm-hmm. So then in vector take this, we take the minimum of our tails, which is going to be tail 2, which is 0, and then we plug this in to calculate our p-value. So we take the minimum, which was the take this, plus 1 to include our OG test stat. We then multiply it by 2 as well, because this is a two-sided test, meaning that we didn't say that red or white is going to be greater or less than the other. We just said that it's going to be a difference. Mm-hmm. We then divide it by n plus 1, which is n, the number of times we reran our for loop, plus 1 to include our OG test stat again. And that's going to be 10,001. And then we get our overall p-value.
So since our p-value was 0.0002, this would mean that our p-value is not greater than 0.05, and we would reject the null hypothesis in favor of the alternative hypothesis. And this gives us the conclusion that there is a statistically significant difference in acidity levels between red and white wine.
Yep. So that's all we got for you in terms of how to do a permutation test, but hopefully this was helpful.
Okay. So after recording, we realized that in this OG test stat, we had it take the mean of the temps. We realized that this mean is not necessary because in the previous vector temp, we already took the means of the two acidities. So all we need in this line is temp 1 minus temp 2, which is the acidities minus each other.
Yeah, and you can see that whether or not we use it, we get the same value because we're taking the mean of one number, which is just that number. So it's redundant, but we recognize that that is not necessary.
Yes.